time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other,
where you put your knowledge to test
and battle it out with a test
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators,
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So, welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. So, we are dealing with control systems, quick revision, semester exams as a part of this lecture 3, chapter 2. So, before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services, and also cracked GATE. Unacademy, let's crack it. And crack GATE and ESE with India's largest learning platform. And you can install Unacademy learning app from the Google Play Store. And you get daily live classes, structured courses, live test and quizzes, unlimited access as well. And you have iconic subscription. You get a personal coach, study tracker, mains question and answer, and all the benefits of Plus. And in Plus subscription, you get daily live classes, structured courses, live test and quizzes, unlimited access as well. Then you can learn from the top educators of the Unacademy, as you can see. And you also have the GATE and ESE batches year-long, and ECE, general studies, and all the Shiva Kumar, welcome to Unacademy. And in iconic subscription, you get all the benefits of Plus along with some special benefits like personal coach, personalized test, study plan, and preparatory study material. And if you want to opt for Plus plan, I suggest you to go for 24 months or 12 months. You can use my code here to get the maximum discount for a limited period of time. And you can also opt for the iconic subscription, which is one of the suggestible one for you. For 24 months, you can use my code YSK10 to get the maximum discount on this. Then coming to today's session, today we will deal Chapter 2 Part A. This is Chapter 2 Part A. As a part of this Chapter 2 Part A, I'll tell you what are the topics that we have in Chapter 2 first. Then we'll deal with the Part A and B. I'll divide it something like this: Part A and Part B. So as a part of Part A, I will discuss time response of first and second order system, and we will discuss time domain specifications, Then in Part B, we will be looking at RH criteria and root locus. Right? In part A, you have one more topic like error constants. Error constants. So let's look at these topics first. Part A today. Today we'll be discussing part A, time response, time domain specifications, error constants. Like question to answer. So let's look at the questions that are given in the previous university examination. I'll just read it out for you from the question papers that I have with me. There is a question that is given. Now, derive the time response of second order underdamped system due to step input. This is a question. Derive the time response of second order underdamped system due to unit step input. So this is a question that is given to us. Now let us look at the answer to this. So before telling you this time response of second order system, let's see what is the time response and what it comprises of actually. So it is a response of any system. So let's say if this is a LTI system, this is C of t and this is, let's say, R of t. So this is the input and output. Now the response of a system here with respect to time C of t versus t, if you try to plot it, in general you'll have the total response is the summation of transient as well as steady state. This is one that you can get. So this is an exponential response. So this is C of t versus t, and this part of the response where before it reaches the steady state is called as the transient response, and after this transient die out we'll call it as steady state response. So the total response of any system is the sum of transient response plus steady state response. So this is what you have to understand first. Then let's look at the next question. Derive the time response of the second order underdamped system. So this order of a system, second order system, if we consider a standard second order system. A second order standard system is given by C of s by R of s is equal to omega n by s square plus 2 zeta omega ns plus omega n square. This is the question that is given. So this is the second order system transfer function. You need to find what is the response that you need to find? Time response for underdamped case. What is that? Underdamped case. Underdamped. For an underdamped system, 0 less than zeta is less than damping ratio is between 0 and 1, and due to what is the input that is given? Step input. So step input is R of t is equal to 1. Therefore what is R of s is equal to 1 by s. So let's try to do that. So we know C of s by R of s is equal to omega n by s square plus 2 zeta omega ns plus omega n square. Now R of s is equal to 1 by s. Let's try to substitute. C of s is equal to omega n by s square plus 2 zeta omega ns plus omega n square into 1 by s. If you take this R of s to the right side. So in order to apply, you need to find C of t from this. So you need to apply inverse Laplace transform. So in order to get this inverse Laplace transform, you need to apply partial fractions to this. You need to apply partial fractions. So what can you write for this? I can write it as a by s plus bs plus c by s square plus 2 zeta omega ns plus omega n square. Hi Karthik, welcome to Unacademy. So let's try to write c of s is equal to omega n by s into s square plus 2 zeta omega ns plus omega n square is equal to a by s plus bs plus c by s square plus 2 zeta omega ns plus omega n square. Now if you are looking at this, you need to find the values of find a and b, sorry, a, b and c. A, B and C values. If you can do that, what do you get? Let's check. You can write omega n is equal to a s square plus 2 zeta omega ns a plus omega n square a plus b s square plus c into s. Take common s square here, so it is a plus b. Take common s common, it is 2 zeta omega ns, sorry, 2 zeta omega na plus c plus omega n square a. Now comparing coefficients on both sides. Sai Teja, good evening. Comparing coefficients on both sides. What will happen? What do you get? This is a constant omega n. You also have a constant. So a omega n square is equal to omega n square, that is equal to 1. So a is equal to 1. This is one value that we got. Now if you compare this a plus b, you do not have anything towards your left. So you can write a plus b is equal to 0. And you know a is equal to 1. Therefore b is equal to minus 1. Then let's try to find the c value. How do you find the c value? So inform other friends to join the session. Inform your friends to join the session. Now compare this term, you do not have anything. 2 zeta omega na plus c is also equal to 0. You do not have anything in the left side. So what is c is equal to? Minus 2 zeta omega na. We already know a, so it is 2 zeta omega n c value. So we got the values of a, b, c. Let's try to substitute that now. Now let's try to substitute in this. So you get omega n by s square plus 2 zeta omega ns plus omega n square is equal to a by s. What is a? 1 by s plus bs. What is b? Minus 1 s plus c. What is c? Minus 2 zeta omega n. Minus 2 zeta omega n by s square plus 2 zeta omega ns plus omega n square. Now if you write this, this is 1 by s minus, if you just take common, s plus 2 zeta omega n by s square plus 2 zeta omega ns plus omega n square. Okay. What did we take? Yeah, this is omega n square by. We did not take it. So this is omega n square by. So we did not take omega n square. This is omega n square by. Yes, you are correct, Sai Teja. This is omega n square by. So this will also be omega n square. So this is omega n square. So a is equal to 1. Yeah. So it's omega n square by s square plus 2 zeta omega ns plus omega n square. This is omega n square by s square plus 2 zeta omega ns plus omega n square. This and this value must be same. Very good. Now coming to this point, I think this is clear. This is omega n square by s square plus 2 zeta omega ns plus omega n square. So once you do this, you will get this value. Now coming to this, 1 by s minus, can I write it as s plus zeta omega n by s square plus 2 zeta omega ns plus omega n square plus zeta omega n by s square plus 2 zeta omega ns plus omega n square. I hope this is correct. See, because if this is a plus 2b by c, I can write a plus b by c plus b by c. I've just separated this 2b. Similarly, I've just separated this 2 zeta omega n. So that is zeta omega n plus zeta omega n. Now, I need to apply inverse Laplace. We know inverse Laplace. I'll just review inverse Laplace. Laplace of, let us say, cos at. What is Laplace of cos at? S by s square plus a square. What is Laplace of sin at? It is a by s square plus a square. Right? Now, what is Laplace of e power at? 1 by s minus a. Laplace of e power minus at? Laplace of e power minus at s plus c. What is first shifting theorem? We already know Laplace of e power at into cos bt. What do you write? First you need to write cos bt, that is s by s square plus a square at s is equal to s minus a. So this is plus b square. Yeah. This is s square plus b square. Now s must be replaced by s minus a whole square plus b square. So this is the Laplace transform. Similarly, Laplace transform of e power at into sin bt. What is that you get? A by s square plus b square. That is a by, here you have b, so I have got b here. S minus a whole square plus b square. So this is first shifting theorem. This is first shifting theorem. Right? Now, let's go back. I want to write this term. Let's listen. I want to write this term s square plus 2 zeta omega ns plus omega n square as this is s plus a. So I should also get s plus a whole square plus b square. This is what I wanted to write this. So if this is s plus zeta omega n, this is also s plus zeta omega n whole square. This must also be s plus zeta omega n whole square. So I just want to modify it in this form. So what I'll do is I'll write this as, so let's write first s plus zeta omega n whole square. What is this s plus zeta omega n whole square? S square plus zeta square omega n square. Yeah, s square plus 2 zeta omega ns plus zeta square omega n square. See, you have these two terms here. But in order to write this as this, what you should do? You should add, listen, you should add plus zeta square omega n square minus zeta square omega n square. Yes or no? So what I'll do is, my aim is to write this as some s plus zeta omega n whole square. So in order to write that, what should I get? S square plus zeta square omega n square plus 2 zeta omega ns. This is what I want to write. But do I have all these terms here? No, I do not have. I do not have this term. I have this, but I do not have this. So I'm just adding and subtracting that term. Right? Now let's see what will happen. Now, this can be written as s plus zeta omega n whole square. So this term will be s plus zeta omega n whole square plus omega n square minus zeta square omega n square. So this is s plus zeta omega n whole square plus, if you take omega n common, that is 1 minus omega n square common, that is 1 minus zeta square. So you can write this as s plus zeta omega n whole square plus omega d square. Since I'll just move this. Yeah, since you can say omega d, we already know damp natural frequency. Omega d is equal to omega n into under root of 1 minus zeta square. So what can I write this now? I'll write in the next slide. I just try to simplify this. Let's see what will happen. This is equal to 1 by s minus s plus zeta omega n by s plus zeta omega n whole square. See, this is s plus zeta. I can write this term as this. I've added this and subtracted this, I got this value. So this is omega d square. Similarly, I can also write this term same as this. So I'll write it as plus zeta omega n by s plus zeta omega n whole square plus omega d square. I guess you have understood how did I write this. Soumya, good evening. Now this is 1 by s minus, how is this? This is s plus a by s plus a whole square plus b square plus, what is zeta omega n by 1 s plus zeta omega n whole square? You need to have something like this. Listen, this is a by s plus a whole square plus b square. Yeah, this is actually b, right? This is b. Now b by s plus b whole square, because I have b here, so this value must also be b, right? So b by, for me to apply this Laplace of e power at into sin bt, it is b by s minus a whole square plus b square. Whatever you have here, you should have here. If you look at this, we have omega d square. Do we have omega d here? No. So I want to multiply and divide by omega d. Now if you do that, this is, if you only consider this term, now first write it omega d by, let's write that, this is omega d by s plus zeta omega n whole square plus omega d square into zeta omega n by omega d. This is, you have a bracket here. Then this is 1 by s minus, we'll apply Laplace inverse here. Now what is apply Laplace inverse? Apply Laplace inverse or inverse Laplace transform. This is already c of s. What is the Laplace inverse of this? Laplace inverse of c of s is equal to Laplace inverse of 1 by s minus Laplace inverse of s plus zeta omega n by s plus zeta omega n whole square plus omega d square plus Laplace inverse of omega d by s plus zeta omega n whole square plus omega d square into zeta omega n by omega d. Now just try to write the Laplace inverse. What is the Laplace inverse of c of s? It is c of t. What is the Laplace inverse of 1 by s? It is 1 minus, this is minus common actually. Now 1 minus, what do you have to write here? Laplace inverse of s plus zeta omega n by s plus zeta omega n. So you'll get e power zeta omega n t, because s is replaced by s minus zeta, s plus zeta omega n, into what is s by s minus a? Cos. So cos omega dt. What is this? E power minus zeta omega n t into sin omega dt, right? So let's write that. So it is e power minus zeta omega n t cos omega dt plus e power minus zeta omega n t sin omega dt into, you have this zeta omega n by omega d. Let's try to simplify this. Zeta omega n by omega d. Zeta omega n by, what is omega d? Omega n into under root of 1 minus zeta square. You can cancel this. What do you get? Zeta by under root of 1 minus zeta square. So I can write this value here. So this is zeta by under root of 1 minus zeta square. So finally you can write c of t is equal to 1 minus, take common e power minus zeta omega n t by under root of 1 minus zeta square also. What do you get here? You should get under root of 1 minus zeta square cos omega dt plus, you have taken common this, you have taken common this as well as this also in the denominator, because you do not have anything in the denominator as 1 by zeta square. I have multiplied it here plus zeta sin omega dt, right? Clear? Now you can write c of t is equal to 1 minus e power minus zeta omega n t by under root of 1 minus zeta square. This is actually, this is damping ratio triangle, that is under root of 1 minus zeta square This is zeta, this is 1. If you write sine theta, this is under root of 1 minus zeta square. So I can write this as sine theta cos omega dt plus zeta is cos theta sine omega dt. So finally you can write c of t is equal to 1 minus e power zeta omega n t by under root of 1 minus zeta square sin a cos b cos a sin b, sine of a plus b, right? So it is sine omega dt plus theta. So this is the value of response. This is the response of second order which system? Under damped system for unit step input. So here in the question paper he can change this unit step and underdamped also. He may also give you undamped or critically damped or something. Clear? Now what is this theta? You know this. So this can be the question. So finally the response is c of t is equal to 1 minus this value. Alright, so this is the answer to the given question. So let's look at this question once again, what has been asked in the question paper. So this was the question. Look at this. You do remember this, we forgot to write this omega n square. So just note, make a correction. This is omega n square. This is omega n square by s square plus 2 zeta omega ns plus omega n square. So have a look at this page. There are only few students who are just listening to this. I want many more students to join the session. Please do inform your friends and ask them to join the sessions so that they'll learn something out of this. Srinivas, good evening. Welcome to Unacademy. I want the rest of the students who are watching to respond. So we are given derive the time response of the second order underdamped system due to unit step input. So the input is unit step and it is an underdamped system. So we'll start with this standard second order system. C of s by r of s is equal to omega n square by s square plus 2 zeta omega ns plus omega n square, and we consider underdamped and step input. The other students who are watching do respond. So then we need to write the input as r of s because it is given for r of s 1 by s. So in order to compute this inverse Laplace, you need to apply partial fractions. So let's try to apply that. We have applied, found the values of a, b and c as well. Then we have taken again this, then we have taken this and substituted a, b, c values. Then try to apply inverse Laplace. I have just tried to split this first because it is s plus zeta omega n. I wrote it as s plus zeta 2 zeta omega n, s plus zeta omega n. Raju, welcome, and plus zeta omega n by this term. I want to write this term. Just be careful here. S square plus zeta omega n s plus omega n square can be written as s plus zeta omega n whole square plus omega d square, or just remember this, you can write this as s plus zeta omega n whole square plus omega n into under root of omega n square 1 minus zeta square. This is what I have just tried to modify here in this part. In this part we have tried to do that. Just try to take down that as a note. Then I have written this, then I have applied Laplace inverse and got this derivation, and finally I got an expression for this by just writing this simplification. Upon simplification you will get this. And because this is an underdamped system, its response would be something like this. Because this is an underdamped system, its response is something like this: c of t versus t. Exponential and sinusoidal, both if you just multiply, You get this. So you can also take the input something like this and you find this error. So I guess you have understood this. This is the time response of second order 100 ampere system for unit step input. Now let's move on to the next question. There is another question that is frequently asked in the examinations. The question is, explain the continuation of this question. I'll write the question that is asked. What is second order? What is second order response of a system? The one that we have done. Uh, Draw the time response of the second order system with unit step. Draw the time response of second order system excited with step response, step input, and explain, or sometimes he'll also give you derive all time domain specifications in detail. This is what is generally asked in the exams. First, I'll write all the time domain specifications because we have already done this part. I'll write what are the time domain specifications. The time domain specifications. So this question is all about the time domain specifications. Time domain specifications. So how do you get this? Let's try to draw that. Let's say this is the response. Let's say this is the response and this is the unit step input. This is time and C of t for 100 ampere case. This is for an under damped case. Now this difference we call it as MP, maximum peak overshoot, and it is denoted in percentage. It is expressed in percentage. This is 1. And the time that is taken to reach this 1 or 100%, we call it as this distance. We call it as rise time. And 50% of this we call it as, this is the 50%, we call it as TD, delay time. And the time it takes for reaching the first peak, we call it as peak time, TP. And the time that it takes for settling down is settling time. So this can be that. So this is settling time, right? So these are the time domain specifications. These are the time domain specifications from graph of a under-damped system. Inform your friends to join the session. We are learning the important topics for external exams or semester exams of university. So I want everyone to join the session. It will be very much useful for all the semester exam students who are writing the exams. Yes. Now we have to derive this one by one. We have to derive these terms one by one. So let's try to derive them. So first let's take rise time denoted by TR. What is it? It is a time taken for the response. It is time taken for a response to reach 10 to 90% of final value. So here C of t is equal to 1. It reaches the rise time maximum value, and this will be from 10 to 90% for different cases. You'll have different values. So C of t is equal to 1. What was C of t? We already know 1 minus e power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta, and we know that Ct value is equal to 1. So 1 is equal to 1 minus e power zeta omega n t by under root of 1 minus zeta square 1 minus zeta square sine omega dt plus theta. You can cancel this one, or if you just take this to the left other side, what do you get? E power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta is equal to 0. Now what is this t? T is the rise time, tr. Now this term cannot be equal to 0, so you can only make this term is equal to 0. So finally you can write sine omega d tr plus theta is equal to 0, that is sine n pi or sine pi, you can write it as. So you can write omega d tr plus theta is equal to pi, or tr is equal to pi minus theta by omega d, that is pi minus, what is theta actually? Tan inverse under root of 1 minus zeta square by zeta by omega d, omega n into under root of 1 minus zeta square. So this is the expression for rise time. Percent for an underdamped case. These are the different definitions. So you need to write, because we are speaking of underdamped system, you can also write 0 to 90%, 0 to 100%, or 10 to 90%. So you just have to make this part is equal to 1. So C of t is 1. Just simplify this, you'll get tr as pi minus theta by omega d. Now, let's look at the second one. It is peak time, denoted by Tp. Peak time, Tp. What is the peak time? Time taken for the response to reach peak value, and here specifically for the very first time. You'll also reach this peak value sometimes, some other times, but it is for the very first time. So generally, to find any peak value or maximum value, this is also called as maximum value. This is also called as maximum value. So in order to find anything, what do? You need to differentiate it, C of t, and equate it to 0. So let's try to consider C of t first, that is 1 minus e power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta. And what is this theta? Let's write this is the value. Now let's try to differentiate this. Apply differentiation on both sides. Differentiation on both sides. When you apply differentiation on both sides, what do you get? dc of t by dt is equal to, one differentiation is 0, and d by dt of e power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta, and you need to equate it to 0. So let's try to write that once again. So dc of t by dt is equal to 0 minus, you need to apply uv rule, because this term you can take common this outside, but this is t, this is also a function of t, and what is this t here now? Tp. All right, so u into v. What is u into v? ub dash plus vu dash. So just apply that. e power minus zeta omega n t by under root of 1 minus zeta square sin omega dt plus theta. What is that? It is cos omega dtp plus theta. This is also tp into omega d, successive differentiation, omega dt plus omega dtp plus, this is minus here already, plus sin omega dtp plus theta into 1 by under root of 1 minus zeta square e power minus zeta omega n t, that is e power minus zeta omega n tp into minus zeta omega n. This is equal to 0. So can I take all these? You cannot make this e power and all to 0. So I'll write this as e power minus zeta omega n tp by under root of 1 minus zeta square omega d is equal to zeta omega n e power minus zeta omega n tp by under root of 1 minus zeta square sin omega d tp plus theta. You can write it this way. Yeah, we did not write this cos, so it is cos omega d tp plus theta. Right, you can differentiate this and equate it to 0. Now let's write this once again. So what is this? E power, let me check. Now let's try to take common these terms. E power minus zeta omega n tp by under root of 1 minus zeta square into, this is minus omega d cos omega d tp, omega d plus cos omega d tp plus theta, plus, this is not plus, this is minus zeta omega n into, you have taken common these two terms, it is sin omega d tp plus theta is equal to 0. Clear? Now you cannot make this equal to 0, but I'll just write it down something like this. You can just take e power minus zeta omega n tp by under root of 1 minus zeta square. This is, what is omega d? We already know what is omega d. It is omega n into under root of 1 minus zeta square. Omega n into under root of 1 minus zeta square. So this is omega n under root of 1 minus zeta square cos omega d tp plus theta minus zeta omega n sin omega d tp plus theta is equal to 0. Now you can also take common this omega n. So let's write that. So e power minus zeta omega n tp by under root of 1 minus zeta square into omega n. I've just take common this omega n. This is under root of 1 minus zeta square cos omega d tp plus zeta into, so this is minus, I'm sorry, this is minus zeta into sin omega d tp plus theta. You also have plus theta here, so let's write this. Yeah, sin omega dtp plus theta minus zeta omega and dt plus theta is equal to 0. No, you cannot make these terms equal to 0. You can only make this term equal to 0. Before that, you can write this is, what is under root of, this is theta. This is under root of 1 minus zeta square. So sin theta is equal to under root of 1 minus. So this is sin theta. And this is cos theta. So sin A cos B minus cos A sin B. What can you write this term, total term, as? Sin of omega d tp plus theta minus theta is equal to 0. You can cancel these two. Now this is sin omega d Tp is equal to sin pi. Finally, you can write omega d Tp is equal to pi. So Tp is equal to pi by omega d. So this is the value of peak time. So this is what peak time, Tp. So Tp is equal to finally pi by omega d. What is pi by omega d? Omega n into under root of 1 minus zeta square. So let me just go back and see. Yeah, you can check this. You have got this. See, if the screen is not clear, do one thing, just click on your screen and you'll get right top corner, you have 3 dots. Click on them, you have the quality and set it to 480. The screen will be very much clear for you. Right, so this is peak time. Now let's see what is the other one. We have rise time, peak time, now maximum peak overshoot and settling time. So let's look at them. Let's see the next one. Maximum peak overshoot. What is it denoted by? It is denoted by MP and denoted in percentage. So what is this maximum peak overshoot is? It is C of Tp minus C of infinity by C of infinity into 100. So this is C of Tp. You can just look at this. This is C of Tp. Here you have Tp, right? This is Tp. C of Tp minus C of infinity is nothing but this value. This value. So this difference with respect to the C of, we are just trying to find the percentage of maximum increase, the percentage of magnitude that is increasing beyond this final value. So it is with respect to this I need to find. So that's the reason we are writing this as C of Tp minus C of infinity by C of Tp. Now we need to find what is the C of Tp and C of infinity. First let us find what is C of infinity. What is C of T? First write that C of T 1 minus e power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta. Now apply C of infinity. C of infinity is equal to 1 minus e power zeta omega n infinity by under root of 1 minus zeta square sine omega t infinity plus theta. Right. Now this value will be equal to 1 minus, this is 0. This value will be 1. So therefore you can find, you can say C of infinity is 1. Now let's find C of Tp. C of Tp. What is C of Tp? C of Tp is equal to, first write what is C of T, then we'll write what is C of Tp. C of T is equal to 1 minus e power zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta. So at t is equal to Tp, you need to find. So C of Tp is equal to 1 minus e power minus zeta omega n Tp by under root of 1 minus zeta square sine omega d Tp plus theta. Now let's try to substitute this value. What is Tp? We already found just now. Tp is pi by omega d. Substitute that in place of this, in place of this. So do that. C of Tp is equal to 1 minus e power minus zeta omega n Tp 1 by omega d by under root of 1 minus zeta square sine omega d into pi by omega d, right? So Tp is equal to pi by omega d plus theta. What do you get? C Tp is equal to C of Tp is equal to 1 minus e power minus, let's e power minus zeta omega n, e power minus zeta omega n into Tp. First let's try to find out this zeta omega n. Zeta omega n Tp. What is it that? Zeta omega n. What is Tp? 1 pi by omega d. What is omega d? Omega n into under root of 1 minus zeta square. Can I cancel this? So this is pi zeta by under root of 1 minus zeta square. So I'll just write this value as e power minus pi zeta by under root of 1 minus zeta square by under root of 1 minus zeta square into sin theta. But we already know that what is from this triangle, what is sin theta is equal to under root of 1 minus zeta square. So you can write this as 1 minus e power minus pi zeta by under root of 1 minus zeta square by under root of 1 minus zeta square into under root of 1 minus zeta square. Can I cancel these two? Yes. So you get 1 minus e power minus pi zeta by under root of 1 minus zeta square. So this is C of Tp. So now you know C of Tp and you know C of T also, C of infinity also. Now we can find percentage MP. Percentage MP is equal to C of Tp minus C of infinity by C of infinity into 100. So what is C of Tp? 1. C of Tp, just now we have found. What is C of Tp? 1 minus e power minus pi zeta. 1 minus e power minus pi zeta by under root of 1 minus zeta square by minus 1. C of infinity is 1 by 1 into 100. Right, so this is what you get. So this is sin omega d, omega d if you cancel you get sin pi plus theta, wherein you will get this is minus sin theta. So this value is minus, so this is 1 plus. So finally you can write 1 plus, so this is plus 1 and minus 1 if we cancel, this is e power minus pi zeta by under root of 1 minus zeta square into 100. So this is percentage MP expression. Percentage MP is equal to e power pi zeta by under root of 1 minus zeta square into 100. So you can write maximum peak overshoot percentage MP. Percentage MP is equal to e power minus pi zeta by under root of 1 minus zeta square into 100. So this is the expression for maximum peak overshoot. Just look at this once again, derivation. Here we have just missed this minus, just remember that. So this will be plus, so you don't have a minus here once it is plus, right? So look at this derivation of maximum peak overshoot. We have seen Tp, now look at this maximum peak overshoot derivation. We have taken this and found the C of infinity and C of Tp also. Then we have substituted. Then we got C of Tp, C of infinity and substituted in this. Then we got this MP. Now let's look at one question. We also have one more thing to do, right? Settling time. We did not do that. So let's also do that. This settling time. Settling time. So let's go and do that. Now just check it out. The fourth one, settling time. Settling time is denoted by TS. Settling time is denoted by TS. So what is the settling time? It is the time taken for the response. It is the time taken for the response to reach steady value after transients die out. Now that is settling time. Now how do you determine this? C of t is equal to 1 minus e power minus zeta omega n t by under root of 1 minus zeta square sine omega dt plus theta. This has two components. One is sinusoidal component, other one is the exponential component. So let's try to compute that. So this is e power minus zeta omega n t and sine, which is other one is a constant omega dt plus theta. This sinusoidal is suppressed by this exponential. So settling time, you do not have any sinusoidal term, so you can neglect this. So I'm just neglecting this. And this is, you have 2 to 5% tolerance, in between 2 to 5% tolerance. So let's write that. So this is, you can write it as e power minus pi zeta omega n. Now this is settling time is equal to 0.02 for 2% tolerance. 2%, right? So for 2% you can write this. So zeta omega n ts is equal to exponential will give you ln 0.02. From this you can write ts is equal to this 0.02 value will give you, this is minus 4. So minus zeta omega n ts is equal to minus 4. Cancel this. So ts is equal to 4 by zeta omega n. So this is settling time. This is for 2% error, 2% tolerance error. If you take the same thing for, if you just try to take the same thing for 5%, now let's write it as 5%. So e power minus zeta omega n ts is equal to 0.05. So you get zeta omega n ts is equal to 3 minus 3. You can cancel this. You get ts is equal to 3 by zeta omega n. So this is the settling time expressions for 2 and 5% tolerance. This is for 2%. This is for 2%. And this is for 5%. Minimum and the maximum value. So this is settling time. So we have seen expressions for rise time tr is equal to pi minus theta by omega d. Next, peak time tp is equal to pi by omega d. Next, settling time ts is equal to 4 by zeta omega n and 3 by zeta omega n. And the last one was maximum peak overshoot. Maximum peak overshoot, that is MP in percentage, is equal to e power minus pi zeta by under root of 1 minus zeta square into 100. Right? So this is what we have done. This is one of the important questions that is generally asked in the exams. So let's also try to solve one problem. Based on this, Let's consider one question. It is given that unity feedback control system has, let's take up one problem from this question papers. So let's look at this question. The question given is, a second order system has, a second order system has a transfer function given 25 by s square plus 8s plus 25. Determine settling time peak overshoot when excited with the unit step input. So just compare this equation with omega n square by s square plus 2 zeta omega ns plus omega n square with 25 by s square plus 8s plus 25. If you are comparing these two, what do you get? Omega n is equal to 5, that is omega n square is 25, implies omega n is equal to 5. Similarly, if you just compare 2 zeta omega n, it is 8, implies what is zeta is equal to, it is 8 by 2 into omega n, 5, 10, so it is 0.8. So zeta is between 0 and 1, so I can say it is an underdamped system, first point. So what are we asked to find? We are asked to find settling time peak overshoot. So let's try to do that. It's a very simple question. Settling time Ts is equal to, let's say, 4 by zeta omega n, or you can also find 3 by zeta omega n. Let's try to find both. 4 by 0.8 into 5 and 3 by 0.8 into 5. So this is 1, 0.8 into 5 is 4, this is 3 by 4. So this is the settling time for 2% and this is settling time for 5%. Now let's consider maximum peak overshoot. Maximum peak overshoot. What is that you get? MP in percentage is equal to e power minus pi zeta by under root of 1 minus zeta square into 100. E power minus pi zeta by under root of 1 minus zeta square. Is that value? Yeah, into 100. So that is e power minus pi into 0.8 by root over 1 minus 0.8 square into 100. So just try to simplify this, you'll get in terms of percentage. So that's it. This is a question that is a very simple question that is given in one of the examinations. Now let's look at the next topic that I told you, that was error constants. And steady state error. So just try to look at this. Whatever we have seen, the second order system response that we have seen just now, we have seen the response. This was the just approximately this is called as, at the steady state, this is called as the error. Steady state error, the error between the actual input and the desired input is called as the error. So whenever you get this error, you need to find that what is the value of that error that you are getting. So now let's look at this. First I'll just give you a block diagram. This is the block diagram G of s, this is H of s, let's call this as E of s, and this as R of s, and this as B of s. So let's try to write what is E of s from this. What is E of s? Let's say this is plus and minus is equal to what? R of s minus B of s. So what is R of s minus what is B of s? It is H of s into C of s. H of s into C of s. But do you know C of s is E of s into G of s? So write it down. R of s minus H of s into C of s. It is E of s into G of s. You can take E of s terms to one side, that is E of s plus H of s into E of s into G of s is equal to R of s. Now take common E of s from this. E of s into 1 plus g of s into h of s is equal to r of s. So what is E of s is equal to r of s by 1 plus g of s into h of s. This is one of the question that is asked. A problem is generally asked on this topic. So let's first discuss that theoretical part. Now E of s is equal to r of s by 1 plus g of s into h of s. Now you need to find error ESS. Error is generally denoted by ESS. To this, to obtain ESS from this, apply final value theorem. What is final value theorem? Let us see. Now what is final value theorem? It states that limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s. So what is ESS? ESS is steady state error, that is equal to limit t tends to infinity E of t is equal to limit s tends to 0 s into E of s. This is what you need to write. So steady state error is equal to limit s tends to 0 s into E of s. So we already know what is E of s. So limit s tends to 0 s into r of s by 1 plus g of s into h of s. So therefore you can write ESS is equal to limit s tends to 0 s into r of s by 1 plus g of s into h of s. From this expression you can say that steady state error is depending on r of s and 1 plus g of s into h of s. So it is depending on both input r of s and 1 plus g of s into h of s, or g of s into h of s, you can say, right? Now let's change that input. So for step input, let's write something like this. For unit step, let's take unit step. For unit step, what is the unit step input? We know unit step input r of s is equal to 1 by s. For a unit step input, r of s is 1 by s. Therefore what is ESS is equal to limit s tends to 0 s into r of s by 1 plus g of s into h of s. That is limit s tends to 0 s into r of s is 1 by s by 1 plus g of s into h of s. You can cancel this. So limit s tends to 0 1 by 1 plus g of s into h of s. So write it down something like this. 1 by 1 plus limit s tends to 0 g of s into h of s. So can I write it as 1 by 1 plus, we'll write it as kp. This kp is called as position error constant. Kp is called as, where kp is equal to limit s tends to 0 g of s into h of s. Called as, what is this called as? This is called as the position error constant. Kp is called as the position error constant. Positional error constant. Right? Similarly you can apply for ramp input. Now what do you get for ramp input? Just to check out for ramp input. For ramp input, what is r of s? You need to define r of s, that is 1 by s square. So what is ESS is equal to limit s tends to 0 s into r of s by 1 plus g of s into h of s. So this is limit s tends to 0 s into, what is r of s? 1 by s square by 1 plus g of s into h of s. So you can cancel one time. So limit s tends to 0 1 by, you can take this s in the denominator. So s plus s into g of s into h of s. Apply limit to this. What do you get? You get limit, you get 1 by, this value is 0 plus limit s tends to 0 s into g of s into h of s. Do not apply s is equal to 0 in this case. It is 1 by limit s tends to 0 s into g of s into h of s. We will write this as 1 by kv. So ess is equal to 1 by kv. So this kv is called as, where kv is equal to velocity. kv is called as velocity error constant. kv is equal to limit s tends to 0 s into g of s into h of s. Similarly, for parabolic input, what is the input is for this parabolic input? What is the input in this parabolic input? R of s is equal to 1 by s cube. So when you write this, ess is equal to limit s tends to 0 s into R of s by 1 plus g of s into h of s. So that is limit s tends to 0 s into 1 by s cube by 1 plus g of s into h of s. So can I write this? You can cancel 2 times. So limit s tends to 0 1 by s square by 1 plus g of s into h of s. You can further write this as limit 1 by s tends to 0 s square plus s square into g of s into h of s. We can apply this. S is equal to 0, this will be 0. You can write 1 by, write it directly like this, 1 by limit s tends to 0 s square into g of s into h of s. So this is written as 1 by ka, where ka is called acceleration error constant. K is called acceleration error constant, and K is equal to limit s tends to 0 s square into g of s into h of s. So finally we got ess is equal to 1 by 1 plus kp, ess is equal to 1 by kv, ess is equal to 1 by ka. This is for unit step input. This is for unit ramp input, and this is for unit parabolic input, right? So these are steady state errors. And also we got error constants as kp is equal to limit s tends to 0 g of s into h of s, and kv is equal to limit s tends to 0 s into g of s into h of s, and ka is equal to limit s tends to 0 s square into g of s into h of s. Now using this g of s into h of s will change. How do that g of s into h of s changes? Let us see. So this g of s into h of s has some form like this: s plus z1 into s plus z2 zeros numerator by s power n into s plus p1 into s plus p2 and so on. This n indicates the type of the system. N will indicate the type of the system. N will indicate type. For type 0, for n is equal to 0, we call it as type 0. So what is g of s into h of s? That is s plus z1 into s plus z2 and so on by s plus p1 into s plus p2 and so on. S power 0 1. Now for n is equal to 1, we'll call it as type 1. So g of s into h of s is equal to s plus z1 into s plus z2 and so on by, you'll get 1s because n is 1, s power 1 s plus p1 into s plus p2 and so on. Now for n is equal to 2, that is type 2 system, g of s into h of s is equal to s plus z1 into s plus z2 and so on by s square into, let's take it something like this, s square into s plus p1 into s plus p2 and so on. So these are the values. Just listen. N is equal to 0, type 0 and you don't get any s. N is equal to 1, type 1, you get 1 s. N is equal to 2, type 2 and s square. So you need to find steady state error for all these, for type 0, type 1, type 2, for different inputs. Let us say steady state error for unit step input. You know what is unit step input steady state error? ESS is equal to 1 by 1 plus kp, where kp is equal to limit s tends to 0 g of s into h of s. Now let's take for steady state error for step input for type 0 system. Type 0, for type 0, what is g of s into h of s is equal to s plus z1 into s plus z2 and so on by s plus p1 into s plus p2 and so on. So find kp first. We need to find kp because this g of s h of s changes, right? So limit s tends to 0 s plus z1 into s plus z2 by s plus p1 into s plus p2 and so on. So if you apply s is equal to 0, what is that you get? You get z1 into z2 by p1 into p2 and so on, right? So this is a constant value. This is a constant value. Therefore, kp is equal to constant. But you should not, it's not that you need to find kp, you need to find ess. What is ess is equal to 1 by 1 plus kp. If kp is constant, ess is also a constant value. Es is also a constant value. So for a step input, error will be, you can just draw it something like this. For this step input, error is it's a constant value. This is a constant value, you can say. So this is ess versus time, c of t versus time, right? Let's look at this. Yeah, c of t versus time, this is ess. It's a constant. So for type 0, let's take for type 1. For type 1, what is that? Kp is equal to limit s tends to 0 g of s into h of s. What is g of s into h of s for type 1? Limit s tends to 0 s plus z1 into s plus z2 and so on by s into s plus p1 into s plus p2 and so on. So if you apply limit s is equal to 0 to this, it is 1 by 0. So kp value will be infinity. When kp is infinity, what is ess is equal to 1 by 1 plus kp. What is kp? Positional error constant. 1 by 1 plus infinity will give you 0. So it is not practically 0, it is approximately 0. Ideally it is 0. So you can say, when you just try to draw a graph to this, so you can just draw an output which is approximately this. So this is c of t versus t. It is ess is approximately 0 for a type 1 system. Now let's take for type 2 system. For type 2 system, for a type 2 system, kp is equal to limit s tends to 0 g of s into h of s. We are doing this for unit step input. So limit s tends to 0 s plus z1 into s plus z2 by s square into s plus p1 into s plus p2. So you would get the same kp. Kp is equal to infinity and ess is equal to 1 by infinity is 0. So you can say finally, for unit step input type 0, type 1, type 2, kp is constant, ess is also equal to constant. Kp is equal to infinity, ESS is equal to 0. Kp is equal to infinity, ESS is equal to 0. This is for unit step input for different types. Now let us consider for unit ramp input. For unit ramp input, what is that? Kv is given. We know that steady state error. What is steady state error? ESS is equal to 1 by Kv. What is Kv is equal to? Limit s tends to 0, s into g of s into h of s. I'll just do this last one. I want you to do the rest of the things. Now, when you find it for, let's do this for type 0, and for type 1 I'll just do it here, and for type 2 also we'll do it here, right? I'll do all the things at one place. So let's find first Kv. What is Kv is equal to? Limit s tends to 0, s into, what is g of s for type 0? S plus z into s plus z2 and so on by s plus p1 into s plus p2. So if you apply s is equal to 0, Kv value will be equal to 0. Therefore, what is ESS is equal to 1 by 0 infinity. Similarly, now if you take this, let's try to differentiate this. Let's try to write the next one. Now, what is for type 1? Kv is equal to limit s tends to 0, s into s plus z by s into s plus p. Can I write it something like this? Type 1, I can cancel these two. So, Kv is a constant value. Therefore, what is ESS is equal to 1 by Kv is also a constant value. Fine. Now, let's look at the third part. For type 2, what is ESS is equal to? Limit s tends to 0, g of s into h of s is equal to s into, this is not Kv, Kv is equal to, yeah. So Kv is equal to limit s tends to 0, s into g of s into h of s. For type 2, what is g of s into h of s? Limit s tends to 0, s into type 2, g of s into h of s by, sorry, s plus z1 into s plus z2 by type 2, s square into s plus p1 into s plus p2 and so on. You just can write. We can cancel one s, that is limit s tends to 0, s plus z1 into s plus z2 and so on by s into s plus p1 and s plus p2 and so on. This will give you infinity because this is denominator, you have 0. So Kv is equal to infinity. What is ESS is equal to 1 by infinity, that is 0. So this is how you get it. This is how you will calculate for ramp input. For ramp input, ESS type 0 infinity, type 1 constant, type 2 0. Similarly, you can do the same thing for, you can also do the same thing for parabolic. And you will be asked a question. I'll just give you how do you do that. I'll just write the question and I want you to solve it. Just write one question. So that there is some university question. Yeah, this is one of the important questions I can say that is frequently asked in your exam. For a unity feedback system, the open loop transfer function g of s is given 10 into s plus 2 by s square into s plus 1. Find position, velocity, acceleration, error constants, and first question is find position, velocity and acceleration, error constants, and second one steady state error when input is. There is one such question that is frequently asked in your exams. R of s is equal to 3 by s minus 2 by s square plus 1 by 3s cube. Sometimes he'll give you in terms of R of s and sometimes he'll also give you in terms of R of t. wherein you need to convert this r of t to r of s. So let's try to do the solution for this. So solution, what is the question that is given? G of s is equal to 10 into s plus 2 by s square into s plus 1. So what is that? First we need to find position error constant. What is kp is equal to limit s tends to 0 g of s into h of s. So what is that? Limit s tends to 0 10 into s plus 2 by s square into s plus 1. Apply s is equal to 0 here. This will be 0. Something by 0 will give you infinity. Now let's write kv. What is kv is equal to limit s tends to 0 s into g of s into h of s. So limit s tends to 0 s into 10 into s plus 2 by s square into s plus 1. Everything is same, only you'll get an s. Even if we cancel this, you'll get kv is also equal to infinity. Now let's write ka. What is ka is equal to limit s tends to 0 s square into g of s into h of s. Apply limit s tends to 0 s square into 10 into s plus 2 by s square into s plus 1. You can cancel this and apply s is equal to 0. This is 10 into 2 by 1, so this is 20. So we got kp is equal to infinity, kv is also equal to infinity, and ka is equal to 20. Now what is the other thing that you need to find? The second question was finding steady state error. What is ESS is equal to limit s tends to 0 s into e of s, that is limit s tends to 0 s into r of s by 1 plus g of s into h of s. You can do in this way. If there is another method to do this, you can also do in that way. I'm just trying to do the general method. S into what is r of s? We are already given r of s in the question. So this is r of s. 3 by s minus 2 by s square plus 1 by 3s cube by 1 plus g of s 10 into s plus 2 by s square into s plus 1. Now just try to simplify this and apply limit s tends to 0. You would get something like this. Just simplify this. I'm just trying to write the final answer, which is helpful for you. So finally you'll get ESS is equal to 1 by 20 into 1 by 3, that is 1 by 60. This is the steady state error. If you just try to simplify this, simplify and try to find this value. So this is one way of doing it, or you can also do it in the other way. See, this is 1 by s, this is a step input, this is 1 by s square, a ramp input, 1 by s cube, parabolic input. So what is the steady state error? You already know kp is infinity. So what is ESS is equal to 0? kb is also infinity. Therefore ESS is equal to 0. So for these two inputs it is ESS is 0. And for the third one, ka is equal to 20. So let's try. I'll just try to tell you that also. Let's do that. Oh, this has come here now. So we know r of s is given as it's 3 by s minus 2 by s square plus 1 by 3 s cube. So this is 3 by s is nothing but for step input, and for that we got kp is equal to infinity, which implies for step input we will find position error constant. So ESS is equal to 1 by 1 plus kp is 0, right? For if you take 2 by s square, you can say it's ramp input, and kb we got it as infinity, so you can write ESS is equal to 1 by kb as 0. And for 1 by 3 s cube, that means for each and every term I'm finding this. This is a parabolic input, and you can find ka as 20. So what is ESS is equal to 1 by ka, but we are already given 1 by 3. So 1 by 3 into ka, 1 by 3 into 20 is 1 by 60. Finally add all these. So ESS is equal to ESS1 plus ESS2 plus ESS3. You can write it as ESS1, 2 and 3. That is 0 plus 0 plus 1 by 60 will give you 1 by 60 ESS. So this is another way. The two problems that I have discussed in this session are very important as far as your external examinations are concerned, and you can also expect much more problems. There are different kinds of problems, but these are the basic fundamental problems that are generally asked in your examinations. So today as a part of this, we have learned chapter 2 part A, that is time response of second order under damped system, and also seen time domain specifications and static error constants, right? So and some problems based on them. This is very useful for your external examinations. And once again, thank you all for joining me today on this session. This is the previous one. Yeah, so as I always tell you, so we have #1 study channels on Unacademy, and do like this video, share this video, subscribe to Unacademy and Unacademy Semester Exams. Use my code YSK10 to get maximum discount on your Unacademy subscription for a limited period. You can also click on this bell icon to get more notification of my classes, and you can also join our Telegram group. Let's crack GATE and ESE with India's largest e-learning platform, Unacademy. Thank you so much for joining me today on this session.